This is a presentation about covalent nomenclature. We've been exposed to ionic nomenclature, where we're combining metals with nonmetals, or metals with polyatomic ions, or even polyatomic ions with each other. Now we're going to talk about when we put nonmetals together. In a covalent compound, we have two nonmetals, at least for the binary covalent compounds that we'll consider. You probably already know many of these compounds. For instance, CO2 is carbon dioxide, CO is carbon monoxide, and H2O is water. You'll notice that all of these contain nonmetals. In terms of the naming, just like what we'd expect in science, sometimes even though we have a standardized nomenclature, sometimes a compound has been around so long that there's no use in trying to convince people of going with the standard nomenclature. So H2O, we don't call it dihydrogen oxide. You can look that up on the web if you want a couple chuckles, but we just call it water. You probably saw in the carbon monoxide and carbon dioxide examples that there was a numbering system involved here. The numbering system basically goes 1 through 10, as we see here: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, based on Greek prefixes for the corresponding numbers. When we're writing formulas for these compounds, I can look at the name and write the formula very easily. Dinitrogen oxide. The di tells me that there are two nitrogens, and there's no prefix in front of the oxide, so there must be one oxide, or one oxygen. Okay, so dinitrogen oxide there. Sulfur dioxide. So there's one sulfur, there's no prefix for the sulfur, so there must be just one, and two oxygens. Nitrogen triiodide, one nitrogen, three iodines. Tetraphosphorus dicoxide. So tetra meaning 4, so there's 4 phosphorus atoms combined with 10 oxygen atoms. Naming is just as easy in covalent nomenclature. I can see in the first compound I have 1 xenon, 4 fluorines, so xenon tetrafluoride. The next one I've got 2 nitrogens and 4 oxygens, so that'd be dinitrogen tetroxide. Sometimes we drop a letter or two so that we don't get more than one vowel in the row. So you'll notice that the A from tetra was dropped in tetroxide. Iodine pentachloride, I had 1 iodine, 5 chlorines. And then the next one here, this is one of my favorite compounds, sulfur hexafluoride. It's one of my favorite compounds because rather than the effects that helium have on your voice, raising your voice an octave or two, sulfur hexafluoride has the exact opposite and lowers your voice an octave or two. And again, if you want a couple chuckles, you can go to the web and observe people taking a hit of sulfur hexafluoride and then speaking. There is some danger in this, in that it is more dense than air and can settle in your lungs and suffocate you. So don't go out and look for a means of purchasing sulfur hexafluoride. There's some non-standard nomenclature involved with covalent compounds. We mentioned water before, even though we could call it dihydrogen oxide. Ammonia is another one. We knew the formulas of all of these compounds before we knew their structures, so the names have just stuck. So ammonia is NH3, and then methane is CH4, and methane is kind of your first foot in the door with organic chemistry. There's a whole nomenclature just for the carbon and its compounds. Okay, just kind of as a new thing to try here, I have embedded a worksheet in this presentation, so and it should be available in the corresponding covalent nomenclature folder as well. But print this out and bring this along to class to turn in. I just want to make sure that everyone is plodding along nicely and keeping up to date with the work in the class.